The number of cricket chirps per minute can be approximated as a linear function. So linear of the temperature in Fahrenheit, degrees Fahrenheit. If the temperature is 60 degrees Fahrenheit, the cricket will chirp 180 times. If the temperature is 80 degrees Fahrenheit, the cricket will chirp 260 times per minute. T is the temperature, and C is the chirps per minute. So they're defining the variables there for us. Algebraically, A, using an ordered pair in the form of TC, so now they're telling us TC, write a linear equation for the chirps per minute, C as a function of T. So C as a function of T. Chirps is a function of temperature. So I can look up here. I recognize I have 60 and 180. So 60 degrees temperature is measured in Fahrenheit. So normally we have your X values here and your Y values here, but T represents our temperature and Y represents our, what does C stand for? Chirps. 180. And then the second one is 80 and 260. Okay, so what's different here is they're telling us we have two sets of order pairs, and then I can just write, tells us, using order pair, write a linear equation. Well, the easiest one might be in slope-intercept form or point-slope form. If I just took those two, then I can just use the formula for slope. Someone tell me the formula for slope. Y equals mx plus b is our linear equation for slope-intercept form, right? But to find slope between 2 points, I can use y2 minus y1. So these are my order pairs. You can call this your first order pair and your second order pair. Substitute it in. Y2 is 260 minus 180 over 80 minus 60. $260 minus 180 is? 60. And 80 minus 60 is 20. Okay. I do want to remind us that although you reduce that, I can get what? This is your change of y over the change of x. Class, what does your y refer to? Number of chirps. So you're going to have 4 more chirps per minute. So plus 4 chirps for every what? 1. What does the x represent? 1 increase in temperature. 1 degree increase in temperature, right? So basically when it gets really hot, there's a lot of chirps. So here is my slope. We can plug that into our formula. So here's another way of getting an equation. This is a little bit more basic way. Now, the x and y you get, you can pick one of these. Does it matter? No, it doesn't. I'll pick this one because the numbers are smaller. 180 for the y and 60 for the x. Class 4 times 60 gives me And if you subtract 240 from both sides, b is equal to negative 60, right? 240, 180 minus 240 gives you negative 60. So what does that mean? You have the slope of 4 and a y-intercept of negative 60. So our equation is 4x minus 60. And then it tells you, in function notation, we said that c as a function of temperature. So we can say c of t. Instead of writing the x, we can have a t here. So here's my equation in function notation. That's today's lesson. C of t equals 4t minus 60. The number of chirps will increase for every 1 minute, and then I subtract that from 60. Alright, let's answer the next question. Using the equation above, determine how many times per minute the cricket chirps if the temperature is 50. If temperature is 50, t equals 55. Put your finger where that goes. We should have temperature that goes here. Let's write that. The number of chirps, t is 55, equals 4 times 55 minus 60. C, number of chirps, based on our temperature of 55 degrees. 4 times 55 gives us 220, and 220 minus 60 gives us 160. And that should make sense in your table of values, because if you kind of put it here, do you see that? If you put 55, then I expect it to be 160 less. Okay, here's a hard part now. Let's make a graph. The x-axis refers to what?
Temperature.
Temperature measured in Fahrenheit. And the y-axis refers to chirps, C, measured per minute. We just called that what? C? So now you have to fit a scale. Well, our temperature is from 55 to 80, so maybe I'll count by tens. 10, 20, 30, 40, 50, I need that one. 60, 70, 80, I need that one. And then chirps goes up to 260, so maybe I count by 25s. So this is 100, 125, 150, 175, 200. So this would be 250. So let's graph this. You can graph your points, and you'll notice that our points are on our equation, because any point on an equation is a solution. So if I did this one first, 4t minus 60, so that's 60, 25, negative 25, negative 50, something like that. There's my starting point, right? And then it's kind of hard to count up 4. Does that make sense? So let's graph our order pairs. 55, 160. So counting by 10. So in between there, 160. Counting by 25, so that's 150, 175, something like right there. And then 60 at 180. That's 175, so we're above that. And then 80 and 260, so 80, 250, this was 275, so maybe just a little bit above that. Now I got fine. And you notice that kind of matches up, doesn't it? Question. Do you think crickets are going to chirp when it's cold?
No.
Oh, they're kind of like you, right? Go into your hood and hide and don't really want to chirp. Can you have negative chirps?
No.
No. So we're kind of focusing on quadrant 1.
I love math. You